pictures, whatever you like.
Okay, so I'm here with Pradeep from TI. He's going to show me
Yes.
the data center wall here, the applications and some of the technology they have. So go ahead.
Yeah, sure, Spencer. So, if you're familiar with AI, unless you've been living under a rock for the last several years, huge growth, right? And what's key about AI in data centers is the amount of power that they demand. It's basically an order of magnitude higher than what is traditionally seen, right? So we're going from processors that are, used to be hundreds of watts. Now we're talking about kilowatts of power for these processors. Then if you look at the actual IT rack itself, it's going from tens of kilowatts, maybe low hundreds of kilowatts, and we're now talking about megawatt level for these IT racks. And when you talk about the overall data center as a whole, we're now talking from tens of megawatts or hundreds of megawatts. We're now talking about gigawatt levels of power. So just through the roof growth.
Just a couple of years.
In just a few short years. And so what that really requires us to do is reimagine and re-architect how you're doing power delivery for the data center, right? And so what we're showing here at our booth here at APEC is what that next generation of power delivery for data centers is going to look like. So today, if you're familiar with how data center power delivery works, you typically will have, let's say, a 50-volt bus bar going up and down the back of your IT rack. And that can get you maybe to like 100 or a couple hundred kilowatts per rack. But what we're seeing the move towards is 800 volts distribution to the IT rack. Now, there's also plus or minus 400 volts being discussed as well, but for simplicity, I'll just call it 800 volts here. And that really enables us to get to these much higher power levels. And so if you look at this, our display over here on the left, TI has we put together a lot of reference designs. And the reason why we do this is we want to demonstrate how our technology works in the application. So on the bottom left is what we're basically showing is you have AC input, so three-phase AC input from the grid. So you have the power grid connected there. Now maybe the power from your data center is going to come from the grid. Maybe you have some gas turbine generators, wherever your power source is, it'll come in from over there. Then what is being introduced in data centers now is this concept of a sidecar power rack, where traditionally you'd have your power supplies, your AC/DC power supplies and other backup energy storage in the IT rack. Now they're pushing them out, they're kicking them out into this sidecar. So here what we have is a reference design that shows a 30 kilowatt AC, three-phase AC input to 800 volt DC output, or plus or minus 400, either way works. And then we have here is a capacitor bank unit. So both of these sorts of pieces of equipment would be in this sidecar rack. And the whole reason why you're doing this is you're trying to improve the overall compute density of what is inside of your IT rack.